So now let's have a look at one example. In this example, we are going to find the median of data 1. And at this point, you know where to find data 1. It's that first data set I gave in your data sheet. So if we're having a look over to data 1, and at this point it makes perfect sense that data 1 here is we're looking at the sorted data. We're looking at the sorted data 1. And so if everybody is looking at data 1 together with me, the sorted version, then this is what data 1 is looking at. So now it's for the long journey waiting ahead of us. It's time I also introduce for me. It's just my own term a little bit sometimes, that in any data set, in any small data set, I would use a term that I call the N number. A capital N in my term right here, and many other instructors also using this famous capital N. But the N number in a data set is simply just to represent the total number of data values. And so in data 1, the N number, if you count together with me here, that would be 40. Or in other words, we are having 40 pieces of data values in data 1. And so, and of course, at this point, yes, I agree that data 1 has the N number being 40 in data 1, it is an even number. And then keeping all that in mind right there. So this is what we're doing. If you're looking at the entire data 1 here, what I see here is, and the sorted data, the organized data, then it started out with a few 60s, say 60s, and quite a few of those, and it runs into the 64s, a few 64s, and then now, so think about it. Totally, we have all 40 data values. So remember the concept of a median of the median is we're looking for the cutting where it has 50% of data below. We're gonna need to look for a cut where it has 50% of data below, and the other half we're gonna have a 50% of data above that cut. And so in that way, so now it makes sense that in our data, since we have a total of 40 pieces of data values, then 50% of those data below that would make 20 of them. And so remember, 50% of 40 is 20 data pieces. So there will be 20 values falling below my cut, falling below my cutting value. And so now these are the data member values right here. We have a few 60s, and if you count all together with me from the bottom up, then the 20th one would be the last 72. So we got quite a few 72, but the last 72 right here. So notice this is the last 72. Because forgive me that I cannot write the entire data set here, but so from the beginning 60s all the way to the last 72, there are 20 of them in that zone of your list. And then after that 72, the next one in your data would be 76, and it repeats a few, and then it ends with the 104 and the 124. And so these other guys are the other 20 pieces of data that stays above our cut. So that's 50% of the data falling below some cut. This is the other 50% of the data of my data 1 falling below that cut. So now magically speaking, and at this point it shouldn't be that magic anymore, but the cut in the way what we're looking for, in how we're looking for, in the goal that we're looking for, the cut needs to be somewhere here, right in exactly in the middle between 72 and 76. The idea now is that if the cut is that last 72, it's not fair because that cut is already falling into the bottom half of the data, and it's not what we're looking for. if you're looking at 76 to be that cut, then that 76 right there already fell into the upper half of the data. So which is also not the median, the cutting value we're looking for, because we're looking for that cutting that divide the data into two equal halves. And so that's the reason why, once again, I drew my red line right here, indicating the cut has to be somewhere exactly in between the 72 and 76. And so now the best compensation for that is now to find the midpoint value. And so the cut here makes sense to be in the middle, exactly in the middle between 72 and 76. And so the standard mathematics, the standard math to find the midpoint of the two value, the middle value of the two is 72 adding with 76, and we're dividing that by 2. And now that is our median. Didn't leave myself enough space here, forgive me. But that is now our median. All right, and so 72 plus 76 divided by 2 is going to give me my final value being 74. And that's my median value in data 1. And so the question arises now is that, wait a minute, but this median is not found in data 1. Of course, it doesn't have to be found in data 1, because right from the beginning, as I was mentioning, the median of a data is simply a cutting value that divides the data into two equal halves. And so what we really looking for here as a goal is to look for a cut value, and that cutting value doesn't need to be part of the data. It's just simply acting as a cutting boundary where, there's half of the data below it and the other half is staying above the data. And so now it makes sense that 74 here doesn't need to be located inside the data. And so now if you're looking closely right here and making the connection to the kind of common answers, like I said earlier in some of the other videos, like that, then when I hear people answering me what a median is, then they commonly say, when your data contain an even number of data, then we're gonna find the two middle values and add them up and divide by 2. So the way we're doing here is also exactly consistent with the way how commonly it has been done. But at this point now it clarifies that looking for the two middle number in an even data set is simply just how we're looking for that. But ultimately, as a goal, what we're looking for is the cutting value where it splits your data into 50% of the data falling below the cut and the other 50% of the data above the cut.